So I'm just going to make a quick video about the iRiver SlimX. This is my favorite CD player of all time. It's one of the thinnest CD players they ever made. And it was in the heyday of MP3 CD players. In 2003 I got mine, 2002, 2003. It's a huge deal. It came in a huge box with a bunch of accessories, and it was $200, and it put all the Walkmans to shame. Love this thing. So I've been over here fixing a few of them. Or like, I wish I could say I was fixing a few of them. They're pretty busted, and usually it's the laser that goes out, unfortunately. But I have one that I'm still trying to fix, and I thought I'd just document what I was looking at. This is not it, actually. This is a parts one. But I'm just going to document a couple of things. Mine is it has one bad channel in it, and so unfortunately I think that bad channel is actually coming from the MCU. Here is the headphone amplifier. This is 3541 is what the chip's marked. And then there is an LW05A chip. This is a Texas Instruments multiplexer. Pin 3 and pin 13 of this multiplexer are the audio inputs. And it selects between those inputs depending on which plug you have connected. If it's going to be the headphone jack or the remote headphone jack or the line out or possibly the radio as well. I don't know exactly how that multiplexer works. I just know it's there and it's switching audio signals. There is another one of these, if I remember correctly, over here, I believe it is. Nope, that's not it. But there's a couple other op amps that are safe to say are for the headphone stage. These JRCs, I believe this is one right here. And also, for sure, on the other side, we have one here. So if you've got any audio channel problems like I do, it's a good place to start. And in fact, I actually traced it out, and the line out goes through these two capacitors to this op amp directly. And what's nice too is on the other side of this, you actually have a lot of stuff labeled for you. If you look closely here, it says, here's a bunch of clock signals and stuff like that. But here is actually L out L, which stands for line out L. And if you look closer around here, I forget where it is exactly, but there's a right out L. And so they're nice points to work with. Here's L out R, actually, is this test point right here. And so you just grab a ground. There's a bunch of ground test points in here too. Here's analog ground 3, for example. And then you can scope out those signals and try to find what's going on. My concern is I vaguely remember blowing up this thing, and I forget how, but I think I remember putting a bunch of voltage through the headphone somehow. Just my test bench doing dumb shit. And I must have blown up something pretty bad. I'm pretty sure it's going to be this guy or this guy. The outputs, because I actually measured the outputs, the multiplexer, and I get nothing on one of the channels for the multiplexer. I replaced the headphone amp. So when you have a problem that bad that goes back several stages, it's a good chance you've blown it on the pre-DAC, because basically the digital microcontroller outputs, I guess the DAC's internal, so it'll output an analog signal, and my guess is the source of that analog signal is going to be blown, and it's going all the way back to the source through the op amps and the multiplexer, which is pretty bad. So I don't know if I'll be able to fix my other unit, but I did fix one of them by doing some laser swap stuff, which is this one, and is currently playing some Norah Jones, which is, okay. But we see here that it has shut off, so maybe this one is having problems too. Might be having some power issue or something. Anyway, great players when they're working. Maybe they're not made for longevity. It's been, 15 years now? So lasers are kind of what goes out on these, unfortunately. But they're beautiful when they're working. Anyway, that's it for this CD reverse engineering stuff. This is Sega Sonic Fan, signing out.